So this is a random video that I wanted to record. It's currently 4 a.m. right now, and yeah, last night I started learning about, like, a night before last night I started learning about neural networks, and I decided to create one from scratch. So you if you are aware of the MNIST dataset, it's basically your handwritten digits. So based on that, I created a simple neural network with like 3 layers. So it's pretty interesting stuff. Here's the code for that. So this is like loading the weights if you already have the weights like saved up somewhere. 1 second. Yeah. So that's that. And like initially the weights and biases. So this is a 3 layer neural network. The first one is not even a layer, it's like layer 0, which is basically your input. So if I open up some drawing, yeah, so if I show you, so the initial layer is like just the input. So it's 700 and something long. One second, let me check. I forgot 1 second. So it's 784 length long array. So basically the images are, the handwritten digits are 28 by 28 pixel. So and we flatten them into a single 1D array, and so 28 by 28 pixel, that's a total of 784 pixels. So the first layer is just like 784 length long, and then there comes the first layer, layer 1, which is usually called the hidden layer. So in our case, I'm using 10 of these neurons in that layer, so a total of 10, and each one will like send their values to each one of the neuron. So that was the I mean, you get the point, right? So that's that. And after that, there's the output layer, which also contains shut the fuck up, man. So there's the output layer, which also contains 10 neurons, so each neuron representing a single digit. So the initial one is 0, then 1, 2, 3, 4, and so on till 9. So these both are 10 long. So this is like the hello world of neural networks. Like there's 2 of them. One is the iris dataset, which is that petal sepal thing, whatever. I'm gonna do that later. And second is this, the MNIST dataset, which is like basically your handwritten digits. So, and this is the most basic implementation of it, using just one hidden layer. You can have multiple hidden layers, and I think that makes the neural network more accurate and strong and stuff like that. But yeah, we are not focusing on that. We are just focusing on learning, apparently. Anyway, so that's how the neural network looks. And yeah, so each of these neurons that we have in the hidden layer and the output layer has a weight and a bias. So those things we are initializing here. So for the first one, we have like 784. So we are giving 784 values to it, right? So that's like 784 long, and 10 value. We have 10 neurons, so 10 of those. So this is just like an array. And then this is the same with the bias, but the bias is like only 1 long because we are adding that to the multiplication. So there's a linear formula for that, that is inside our forward propagation. So if you see, yeah, so the weights, we are multiplying that with the x is our input value, and then adding our bias to it. So that's the forward propagation. We are currently for this we are using the method of gradient descent. I'm not going to explain gradient descent right now because that's like pretty complicated in itself. Not even complicated, I'm just like too bored to explain that. So in that we are going through a 3-phase process. So the first phase is like the forward propagation, second phase is the backward propagation, and third phase is updating the values which we get after after the backward propagation. After the backward propagation we get the derivatives like let's just say that is the error that we are having. So in the forward propagation we predict the values based on our weights and biases that we have right now, and in the backward propagation what happens is we pass the actual answer. So like if the answer is 7, so we pass the array of like 0 0 0 till the it's like this. So this for example this returned a value of 0 point something, and then this also returned 0 point something, and then for example this said like it predicted the number to be 2, so this should be around 0.9 something, and then the rest of the numbers are something else, and the actual answer is like it's 7. So what we will have do is 0 0 0 0 till the number till the index 7, so that will be completely 1, and then rest is also 0, 8 and 9. So this is called the one hot, I guess, right? Yeah, this is called the one hot Y thing. So what that does is it creates a array based on the actual solution and sends that through the backward propagation method. And like what backward propagation method does, if you like read this one second. So this is the documentation I wrote. I'm like pretty bad at explaining it, but yeah, I'm doing my best. So this is the graph, learning graph. Yeah, so the backward propagation is something like that. So why did we do that? Yeah, so we are derivative of z2. Z2 is our like predictions by the by the output layer, and like we are subtracting a2. Sorry, a2 is the prediction. Z is your it's a linear solution. After the linear solution we apply the activation function to it, and after applying the activation function we get the output value. So for the first one we are doing the linear equation, so weights multiplied by the input value plus the bias, and then we are applying the activation function. So both we have two layers, right? The hidden layer and the output layer. So the hidden layer is hidden layer applies the function, the activation function ReLU. ReLU is your rectified linear unit. So rectified linear unit, and what that does is it takes a number, and this is basically a function. It takes a number, and if the number is less than 0 it will just return 0, and if it's more than 0 it returns that exact number. And next is softmax, and softmax is let me just pull up my notes I have written. Yeah, softmax is just like converts the output, the array of output, into a prediction array. So in short, if I try to explain it, so if you look at the formula itself, so we are just doing we are taking the exponential of that number. For each number we are taking the exponential of that number, and then we are dividing that with the entire sum of all the numbers, like the exponential of all the numbers in that array. So this basically returns the percentage of that number, like the percentage of that number within the array itself. So it gives a probability. If you sum all the numbers that the softmax function returns, it will be equal to 1. So if I try to explain it here, so like it's basically n and I equals to 1, and softmax, if I apply this to softmax, so xi, sum of all the numbers is equals to 1. So that is just the softmax function, activation function. I don't know, I probably did a really bad job explaining that, but yeah, anyway. So that's the softmax, that is what we apply at the output layer. So after that we get the prediction that our neural network made, and now we do backward propagation. So what backward propagation does is, it, yeah, as I was explaining, it takes the creates a one hot y value of the that particular sample, and passes that back to the neural network. So it compares the result it provided with the actual answer, and then tweaks the weights and biases based on the error rate. So it's actually way too much complicated. It took me hours to understand it myself, so I'm not gonna do a good job explaining this, but you can just read this code here, and like I have written about it here. So this is the loss function. It's like of no use actually. We just like find the loss with the help of this function. So this is like categorical cross entropy loss, and we use that for the graph and nothing else. It's of no use other than that. Anyway, yeah, so that's that. And yeah, if I show you this, so working off it, so you can see the blue one is training accuracy, the yellow orange one is testing accuracy, and the red line is the loss. So loss is going down and accuracy is increasing for both test and train accuracy, and you can see the values here. So test accuracy is 87%, train accuracy 89. Anyway, I have already trained the models and saved them, so this will take a while to happen, so I'm not gonna wait for that long. So based on this, I created a GUI as well, which does this live. So like if I write one here, so yeah, it predicts it like instantly. It is like really fast. And if I do 2, yeah, it did the 2, then 3. Yeah, it's kind of bad, I guess. It worked bad then, yeah, 3. And then 4, it's not gonna get 4, I'm pretty sure. It's just says 7 for some reason. Yeah, 4. Now it works. Now it come anyway. So 5, it thinks that's a 6. Now it thinks that is up. Whoa. Nice. Now it thinks that's a 3. Anyway, 8. Okay, it got the 8. Nice. And the 9. Yeah. And the 0, of course, and it's not gonna get it. Yeah. Okay, you have to make it big enough. Anyway, so that's that. That's the GUI. That's the live thing. The GUI is made with Tkinter, and yeah, that's pretty much it, I guess. I'll link the repository down in the description, I guess. And yeah, I was just feeling like explaining this thing to someone. So here it is. Anyway, good night.